Assalamualaikum and hi everyone. Let's continue with the third part of numerical computation and expression. Last time, we have looked at escape sequences, variables and how to initialize them, the valid names or identifiers for our variables, classes, constants and also methods. And we have also looked at for constant, we need to have the keyword final. In this third part, we will look at the 8 primitive data types in Java and about assignment, which is assigning values to the variables or constants for different data types. In Java, there are 8 primitive data types. The differences among these are in terms of the kind of values, either numbers, letters, or other types, the memory they use, and also the range of values, which will be shown in the next few slides. Out of the 8 primitive data types, there are 4 that represent integers or numbers, such as the value 1, 2, 3, 99, and other numbers. They are byte, short, int, and long. We will look at the differences among these in the next slide. For numbers with decimal point or floating point numbers, we have 2 types, which are float and double. To represent characters, such as a letter, symbols, or other kind of characters, we will use the char type. And lastly, to represent the value true or false, we have Boolean. We have seen Boolean before this. This slide shows the different types, the kind of value, memory used, and also the value range. It depends on the precision and how big the values that you want and need to have in your program. For example, we can compare byte and short. Byte and short have integer values, which means they represent numbers. If we look at the range of values, we can see that byte has the range from -128 until 127, while short covers from -32,768 to 32,767, meaning that it covers larger numbers. In terms of the memory used to store each of the data type, larger range requires larger memory. Byte data type only takes 1 byte or 8 bits because it can be used for numbers from -128 to 127. While short data type takes 2 bytes or 16 bits memory as it covers numbers up to 32,000. This memory part of the data relates back to topic 1, where we have looked at how data is kept in the memory depending on the size. This slide compares the memory used to store each of the data type. You can see clearer from this slide so that whichever type that you choose to use in your program, if you don't really make use of it, it will just be a waste of memory. It does not matter much in our current computers as we are not using all of our memory. But if we have limited memory, this is useful to know before writing the code. Numeric primitive data. The difference between the numeric primitive types is their size and the values that they can store. For example, as we have seen and discussed in the class before, the precision in data type float and type double. Float can have 7 significant digits, while the type double can have up to 16 significant digits. We can run this code to see if this is correct by writing float number equal to 1.1234567890123456789f. Right? Remember that for float, you have to write f at the end of it. And then we will print it out using system.out.println number. And then on the next line, we have double number 1 and it has the same value as float before. And then it will print out using system.out.println. If we run this code, what do you think the output that we will get? For the float number, it will display 1.1234568, which is 7 significant digits. For the double number, it displays up to the maximum 16 significant digits. You can try with other data types to check the minimum and maximum value that these different types can have. What happens if we try to access numbers that are not within the range of the data type? We will get overflow. Overflow happens when the storage of a variable cannot hold the result. For example, here is the type int. Referring back to the previous slides, we know that the maximum value for an int is 2,147,483,647. It covers a wide range. However, in this example here, we try to give our data type int for a variable called 3 billion the value of 3 billions. It will print out negative 1,294,976,296. Why do you think this happened? The value 3 billion that we tried to give to the data type int has overflowed the int capacity. As mentioned previously, int can only hold values up to around 2.14 billion. So, if we want to have values more than 2.14 billion, we should use type long because it has a larger range of 10 to the power of 18 rather than using int. In your code and your program, you should select the best suitable data type for the values that you are going to store. Normally, we would use int for integers and double for floating point numbers for higher precision. You can choose to use other types as well. An assignment statement is used to assign a value to a variable. We use the equal sign to do it. For example, answer equal to 42, which means a variable called answer is given the value 42. We have looked at this kind of concept when we learned on how to initialize our variables. Our variable will be at the left side, and any values which can be the initial value or any kind of arithmetic operations will happen at the right side. The syntax in assignment statement is variable equal expression, where expression can be another variable, a literal or constant such as a number, or something more complicated which combines variables and literals using operators such as addition and subtraction. We can also declare and have the expression on the same line, meaning that the expression is the initialization value. For example, amount equal to 3.99, meaning that we have declared it previously. So perhaps we have already written somewhere in our code double amount semicolon, then on another line, amount equal to 3.99. The same goes for the other examples here, such as first initial equal single quote W, which is of type char, and also int or double for score and eggs per basket. For the variable score, number of cuts and handicap are two other variables, meaning that it combines two variables. So the more complete code could be int number of cuts equal to 9, int handicap equal to 3. These values are just some random numbers. It can be any values. Then, to calculate it, we can have int score equal to number of cuts plus handicap, which is the same as score equal to 9 plus 3. Let's look at another example. Say that we have this code in a class called example. We have a data type string called hello, and it has the value hello. We also have string world, and it has the value world. For string, the value needs to be in double quotes. Then we have another string called string in small letter s, equal to hello plus world. Is this code valid? What do you think the output will be if we run this code? To revise what we have learned last time, we know that string is a reserved word. But if we use string in small letter s, it is no longer a reserved word. Only string in capital letter S is a reserved word. So this code is valid. In string equal variable hello plus variable world, we can combine the two string values that we have. So variable string will have the value of hello world. If you look at the output in the green box, You can see that the word hello and world is without a space in between them. That is because that is how the values are in our variable hello and variable world. To have a space, there are several ways to do it. The first way is by having the value at variable hello equal to hello, and then we have a space as shown in red. So if we run this code, it will display hello space world. The second way is by having the space as part of the variable world, so it becomes string world equal to space world. When you run this code, the output will be hello space world. The third way is by concatenating space in the string variable by writing string equal to variable hello plus double quote space double quote and then plus world. So this one, if you run it, it will display hello space world. It all depends on which way you prefer when writing the code. All of these give the same output, only different style and ways of doing it. Assignment compatibilities. A value of one type can be assigned to a variable of any type further to the right, meaning that smaller data types or smaller values to contain larger values by changing the data type. For example, we can have byte to int or int to double. Let's look at this partial of a code where we have int number equal to 5, double number equal to number. So basically, variable double number should have the value of 5 as well. But double number is of type double, which means it has the decimal point. What do you think will be printed out from the system.out.println? It will display 5.0 instead of just 5. So over here, we can see that we are giving the value of int to our double. What should we do if we want to display only the value 5 when we print out our double number variable? Instead of using system.out.println, we can use system.out.printf %.0f. So this will display only the value 5. However, the type of double number is still a double. Variable of any type cannot be assigned to the type further to the left. Left to right data type is okay, but not from right to the left data types. Say that we have this code. We have double number equal to 5, int number equal to number, and then we have system.out.println int number. If we compile it, it will give an error that says incompatible types, possible lossy conversion from double to int. We will look into how to do it, which is from double to int, for example, in the next part, which is on data conversion. When we have several numbers, and if at least one of the numbers is a floating point type and the rest are integers, the result will be a floating point type. What it meant by this is, say that we do 15 divided by 3, it will give us 5. But if we do 15 divided by 3.0 or 15.0 divided by 3, we will always get 5.0 as the output. To simplify this for our understanding, we can assume this as when we do 15 divided by 3, that is basically data type int divided by int. So the result will be of type int as well. That is why we get the value 5. If we do 15 divided by 3.0, that is int divided by double. Double has a larger storage and covers larger range than int. It also has precision. So the result will be of type double. That is why the output is 5.0. Similarly, it is the same for 15.0 divided by 3.0, and also if we do 15.0 divided by 3. For type char, you can assign a value of type char to a variable of type int. As we have seen in ASCII code before, when we assign char to int, it will give the representation number of the character. For example, char letter single quote A, int letter value letter. When we do system.out.println, what do you think the output will be? It will show 65, which is the number that represents the letter A. You can refer to the ASCII table to check. Also, for char, we can assign numbers to it instead of characters or letters. For example, char letter equal to 65. When we do system.out.println and print out the variable letter, it will display the value A, which is represented by the value 65. Java is said to be strongly typed. You can't, for example, assign a floating point value to a variable that is declared to store an integer. Sometimes, conversions between numbers are possible. For example, if we have double variable equal to 7, it will display 7.0 because type double has the decimal point even though we initialize the value to 7. However, we cannot do int variable equal to 7.0. That is invalid because integer should not have any floating point value. Assignment evaluation. The expression on the right-hand side of the assignment operator equal is evaluated first. The result is used to set the value of the variable on the left-hand side of the assignment operator. As we have discussed in the class before, any calculation, for example, will be done at the right side. In simple words, normally in mathematics, we will do 1 plus 1 equal to 2. But in programming, we will do 2 is equal to 1 plus 1. Initializing variables. A variable that has been declared but not yet given a value is said to be uninitialized. Uninitialized primitive variables may have a default value. However, it is a good practice not to rely on the default value. For example, for class variables, what we have seen so far are local variables where the variables are valid only within the main method. Uninitialized class variables have the value null or no number or 0. What does it mean by a class variable? If we declare any variables just below the class header, that is class variables, meaning that it can be accessed in any methods in that class and other classes depending on the access given. What we have done so far, we have variables in the main method. So, if we have other methods, they cannot access to the variables that we have written in the main method. Let's look at this class called example to understand more about class variable and local variable. Below the class header example, we have int number, and that is a class variable. Then we have the main method, and we have another variable called int number equal to 9. This is a local variable, meaning that it is only known in the main method. In the previous part, we have seen that we cannot declare our variable more than once. Over here, we have declared class variable and local variable with the same name or identifier. Do you think that this is valid? It is valid because when we have the local variable, in the main method, it will use the value from the local variable. What do you think will be displayed when we run this code? Is it the value 9 or is it the value 0? Because it will read from the local variable, it will display 9. What if we remove the local variable? So I comment this one out using /. What will be the output if we run this code? Does it even compile? It will display 0 because by default, class variable of type int has the value of 0. You can try with double, char, string, and boolean to see what is their default values. If you run this code, for int, it will display 0, double is 0.0, char is 0000, and string is null. This slide here shows that when you have class variable, it can be accessed by any methods in that class. In this example, the value number equal to 5 can be accessed in main method and also in method1 method. Local variable number equal to 2 cannot be accessed by method1. Only main can access it. Try and run this code to understand it. Uncomment the local variable and see what will be displayed on the screen if you have local variable. Initializing variables. To protect against an uninitialized variable, assign a value at the time the variable is declared. For example, int count equal to 0. As we have seen before, we can always write it in two separate lines, where we first declare the variable and only in the second line that we initialize it. For example, on the first line we have int count semicolon, and then in the next line we can write count equal to 0. The syntax in initializing variable is if we want to declare and initialize, we will have the data type and then the name of the variable equal to some expression. If we have declared it previously, we can initialize it in different line. Say that we have two or more variables with the same data type. We can use the comma to declare and initialize it within one line. For example, say that if we have int number1 equal to 5 and then on the next line int number2 equal to 10. This is the same as if we write int number1 equal to 5, number2 equal to 10. However, if we declare our variable, for example, int number1, number2, then on the next line only initializing it, we have to initialize number1 and number2 separately. They cannot use the comma, so it needs to be number1 equal to 5 semicolon and then on the next line number2 equal to 10 semicolon. Simple screen output. Say that we have a variable called count. We can use the printline method to display some sentences. For example, the string literal the count is, and followed by the value of the variable count. Remember that we need to use the plus sign to concatenate the string. For this example, the output is the count is 45, as we initialize the variable count to the value 45. E notation is also called scientific notation or floating point notation. For example, the value here can be written as 8.65E8. That is the same as 8.56 times 10 to the power of 8. 0.000483 can be written as 4.83 e to the power of minus 4, which is the same as 4.83 times 10 to the power of minus 4. The number in front of the e does not need to contain a decimal point, meaning it can be any number. Say that if we have 4e3, that is the same as the value 4000.0 or 4 times 10 to the power of 3. And it is also the same if we use the power method, POW, in the maths class. I have mentioned about the maths class during our lesson. You can check the Java API for the methods that maths class has. For this power method, what I wrote here is maths.power 10,3, which is 10 to the power of 3. It will give 1000 and then it will be multiplied with the value 4. So that's why the output is 4000.0. Imprecision in floating point numbers. Floating point numbers often are only approximations since they are stored with a finite number of bits. So if we have 1.0 divided by 3.0, the value is slightly less than 1 over 3. If we do system.out.println 1.0 divided by 3.0, we will get 0.33, where it is up to 16 significant digits. So supposedly, if we do 1.0 divided by 3.0 plus 1.0 divided by 3.0, and then add another one of it, the value we should get is less than 1. For characters, a char variable stores a single character. Character literals are delimited by single quotes, for example, single quote A. It can be declared as char top grade and initialize it equal to single quote A. Char is the data type of a variable. String, on the other hand, is an object. Note that the difference between a primitive character variable, which holds only one character, and a string object, which can hold multiple characters. In a string, we will use double quotes. Char uses single quote. A character set is an ordered list of characters, with each character corresponding to a unique number. A char variable in Java can store any character from the Unicode character set. The Unicode character set uses 16 bits per character. It is an international character set containing symbols and characters from many world languages. The ASCII character set is older and smaller than Unicode, but it is still quite popular. The ASCII characters are a subset of the Unicode character set, which include the uppercase letters, lowercase letters, punctuation, digits, special symbols, and also control characters. We have looked at the ASCII table in topic 1. You can refer to the table to see the characters that it contains. Now, let's look at Boolean. A Boolean value represents a true or false condition. The reserved words true and false are the only valid values for a Boolean type. For example, Boolean done equal to false. See here that the word false, F is in small letter. If the Boolean is true, T is also in small letter. A Boolean variable can also be used to represent any two states, such as a light bulb being on or off. That's all for the third part of topic 3. To summarize, we have looked at the 8 primitive data types and the differences between them in terms of the storage and also the range. We have also looked at assignment, where we initialize the values and also assigning the variables to other variables or doing some arithmetic operations.